Welcome back again to the channel. Now, in today's video, we are going to continue, in our DevOps Zero to Hero series. Today, we want to look at networking on AWS. We've been looking at different services on AWS. Prior to now, we've looked at S3, we've looked at IAM, and some other services as well. Now, the reason why we're looking at all of these services is because having fundamental knowledge about all of these services is very important by the time you start doing your hands-on project. Because if you don't understand how these services, what they do, how to use them, it will be difficult for you to actually understand how to combine these services together. And that is why we are not skipping the fundamentals, right? We are actually going through the fundamentals so that you understand what exactly the services do. And later on, by the time we're doing our project, you have understanding of how to combine the services together. Okay, that is the reason we're not skipping any, of the fundamentals. Now, today we want to look at VPC. Now, prior to now, we have already talked about networking. In one of the videos, we've talked about understanding the decimal binary, conversion. We've talked about, networking. We've talked about a CIDR. We've talked about the classes of IP addresses that we have. We talked about class A, B, and C, and what each of those classes mean. And of course, we've also discussed in a networking video, which I'll link in this video, about the public IP addresses, the private IP addresses, what the difference is, and how to identify a public address from a private address. So today our focus is just basically going into AWS and to see how we can create a VPC in our AWS environment, and basically to understand what a public subnet is on AWS and what a private subnet is on AWS, and also to understand the different gateways, particularly two gateways that we're going to be looking at in today's video. We're going to be looking at the Internet Gateway, and we're also going to be looking at the NAT Gateway, right? We want to understand the difference between these two gateways, the Internet Gateway and the NAT Gateway. Okay, now without any further ado, let's get right into the business of today. Now, on the AWS dashboard, when you search here, you can search for VPC. Okay, and that will take you directly to the page that I have on my screen right now. Now, every region in AWS has a default VPC created. And that is why on AWS, you don't necessarily have to create a VPC before you can start launching your instances. I mean, on AWS, you can launch your instance without even creating a VPC, because there is a default VPC that is available to you that you can leverage to create your EC2 instances or your database or whatever service you want to create that actually needs a VPC. All right. Now, here we have a default VPC created for us. So if I click on your VPCs here, I can see here that I have a default VPC created, and that is how it is in every region. Now, regardless of the region you choose or you are using, you have a default VPC, and that default VPC comes with this particular CIDR. In fact, this is a CIDR that AWS uses in all the regions. All right. So now you want to create your own VPC. Okay, and we already know that your VPC is more like your network, and then for every network you have what you call a subnetwork, which means you have to divide the whole network into subnetworks, right? Basically isolating, your networks. Okay, now on AWS, your region is more like the whole area. Then you have what you call availability zones. So availability zone is like compartmentalizing your region, right? So you have the region. So for example, I'm using the Oregon region, which is the US West 2 region. Now in this region has 4 availability zones. So if I click on my subnet, I will see 4 subnet in this particular region. All right. Now, again, from our previous videos, we already talked about the difference between a region and availability zone, right? Availability zone is basically distinct data centers within a region. So which means within the US West 2, we have different availability zones, that are actually apart from one another. Right, but of course they are connected logically, and that is the reason why they can actually share resources amongst themselves. Okay, so in this region, for example, there are 4 availability zones, and that means we have 4 subnets, right? Each availability zone, is a subnet. So you can say that a subnet is equal to an availability zone. Okay, you can say that a subnet is what is equal to an availability zone, because normally what you should have is one subnet per one AZ, which means you have one zone, all right, and then you have a subnet in that particular availability zone. All right. Now, our goal here is to understand all of these things. So again, you also have the route table, right? So you have the VPC, you have the subnet. So the VPC is the whole network, which is created at the regional level. The subnet is created at the zonal level, right? At the availability zone level. All right. And each subnet basically represents an AZ. Okay. Now here you also have the route tables. Now, what is the route table? Now, when you create your VPC and you create your subnet, automatically, it does not mean that since you have a VPC and a subnet, your resources can start having access to the internet and things like that. No. All right. Now, what you do is basically that you have to create a route table. So the process is like this. So you create a VPC, you create a subnet, and then you create a gateway. So it can be an internet gateway, it can be a NAT gateway, depending on how you want your resource to be accessed or how you want your resources to access the internet. Okay, so there are two things. So how do you want your resource to access the internet and how you want people to access your resource as well, right? So that will determine the gateway that you're going to be creating. So whether it's going to be an internet gateway or a NAT gateway. Okay, now here you have the routing. Now, what is the duty or the function of the routing? And by the way, let me just mention here that when you create a VPC would come with, all right, a route table by default, and then it comes with a security group by default. So which means when you create a VPC, two things are created. A route table is created, and then its default security group is also created. All right. Now here, this is the default route table for our default VPC, right? And if I go to route, I will see here that I have a route configuration. So here I have the IP address of the VPC, and the target here says local, which means every resources or services that I create on this particular VPC, regardless of the subnet, they have the privilege of communicating with themselves. All right. So I really don't have to configure any kind of routing, okay, to actually communicate amongst resources that are available in my VPC. So which means if I create a resource in subnet A and I create another resource in subnet B, as long as the both subnet are in the same VPC, all right, they can actually communicate with one another. Okay, now, and that is what you have here. The CIDR here is the CIDR of the VPC, not of the individual subnet. All right, so this CIDR is what? Is the CIDR of your VPC and not the CIDR of your subnet. And the target here says basically what? Is local. So that means, like I said earlier, if you have a resource in subnet A and you have another one in subnet B, as long as they belong to the same VPC, they can communicate with one another. Right? It's just like a mother and her children, right? So if you belong to the same family, you don't need to go through any kind of appointment to see your brother or to talk to your sister. I mean, you can call up your brother anytime and say, hey, bro, how are you? Can I talk to you? And all of that. I mean, you belong to the same mother, you belong to the same father, you belong to the same family. So you don't need an external party to talk to one another. Okay, so the same thing also applies here. As long as the subnet belongs to the same VPC, resources created in any of the subnet can actually talk to one another. And that is why the target here says local. Now, in some cases, you also have to talk to an external party, right? You have resources, you have services that needs to do something on the internet, right? They need to download updates from the internet and things like that. And that is where your internet gateway comes into the picture. Right? So here you see that the destination says 00. Now in the networking video, all right, that we talked about, that we already done, that we did already, all right, we talked about, the different CIDRs that we have and different IP addresses and all of that. And one of the IP addresses that we mentioned is the 000/0. And we said that IP address means, all right, anywhere. I mean, anything, which means if there's anything that my resources or my service is trying to access, that is not available locally, then you can actually reach out to the internet gateway to help you to source for that particular resource. Okay, and that is why we need an internet gateway. So in this case, if there's anything that I need within my family that is not available to me in that family, I can actually talk to somebody that I know, all right, to help me with that. Okay, I mean, that is also the idea here. So if there's any service or any resource or any update that my server is trying to download or my service is trying to download that cannot be found within the VPC, then it will reach out to the internet gateway, and the internet gateway, of course, is connected to the internet. It is internet facing, and then the internet gateway can help to navigate and download whatever service my resource needs. Is that all right? And that is why you need an internet gateway right here. Now, you may be wondering, so what is the purpose of the NAT gateway? Okay, now I said earlier, I said there are two ways to actually configure, access to your resources. So sometimes you need your resources to be accessed from the internet, all right, publicly. And then at another time, you'd want to shield your resources from being accessed from the internet publicly. But at the same time, you want that same resource to have access to the internet. So which means you have some resources that you want to expose publicly. So which means, anybody should be able to access them from the internet. Now, such resources will need what? An internet gateway. Okay, but there are some resources like your database, okay, your web servers. These are resources you do not want to expose directly to the internet. So in that instance, you're going to need what? A NAT gateway. All right, because these resources at the end of the day, they still need to download update as well. Your database needs to download some minor updates, some patches. Your EC2 instance, you need to install Aperture, you need to update some services regularly and all of that. So at the end of the day, you're still going to need internet access. All right, but you don't want to expose these resources directly to the internet, and that is the purpose of the NAT gateway. So the NAT gateway, the full meaning of NAT basically means network address translation, which means your NAT gateway is going to act as a shield. All right. So instead of exposing your resources directly to the internet, the request will be routed through the NAT gateway to your resources. Right. So which means your resources will not be able to be accessed directly from the internet. All right. But then the routing will go through the NAT gateway. So if your resource also wants to download any update or anything, it will go through the NAT gateway. Okay, so that is the difference between the internet gateway and the NAT gateway. All right, so now let's go ahead and let us create our own VPC, our own subnet, and let's see what the process, all right, looks like. So I'm going to go to my VPC. I'm going to click on create a VPC. So here you have two options. So VPC only on VPC and more. Now, the VPC only basically is just, creating the VPCs, manually and all of that. VPC and more will actually combine all of the things together, which means with VPC and more, you can create your routables, your NAT gateway, your internet gateway, and, anything that you need. But let's go with the VPC and more since we're learning here. So for the VPC only, you can name your VPC. The tag is actually optional because if you look at the default VPC that we also have, it does not have any tag. But on AWS, tag is very, very important. It's a way to identify your resources and to basically give your colleagues or your team members an idea of what the resource is actually about. Okay, so tag, it may be optional, but it is something that I really, really recommend that you learn how to do. For every organization, they have a naming convention that they actually use, all right, for their tag. So it is important for us to tag our resources for the purpose of identification and for understanding what that resource is actually doing or is meant to do within, all right, our environment. So the name tag here, I can call these, so let's just call this class VPC. And then here, my IPv4 CIDR block. So I need to give my VPC a CIDR, which means, you already know what a CIDR is. You have to give your VPC, all right, if an IP range, okay? So I'm going to just come here and say 31.0.0.0. And by the way, I'm going to use the same, CIDR block that my default VPC, all right, has already. And in AWS, you can actually you can have two VPCs that will have the same CIDR. It's not a problem on AWS, all right? So here, I'm just going to go here and I'm going to say create VPC. All right, now my VPC has been created. Okay, and of course I don't have any subnet, and you see here, like I told us earlier, you have a routable created for you by default. So for every VPC you create, a routable, all right, is created for you automatically. All right, so that is what you have right there. Now, a few things that I just want to point out here is that when you create a VPC like this, you can't actually modify your CIDR, okay? Your CIDR address cannot be modified, which means if you realize that this CIDR is actually not correct and you want to change it, there's actually no way to change that. Because if you come here to actions, right now you can see edit CIDR right here, but that will not allow you to basically edit the CIDR. I mean, what you can see here says what? Remove. And even this remove is grayed out, which means you cannot actually delete the CIDR. Okay, so the only thing that you can do is basically to delete this VPC and you recreate it again, right? That's the only option you have for now. Okay, now that is one thing I thought to call our attention to. Now, the second thing I want to call our attention to is these two things. So there's DNS hostname and there's DNS resolution. Okay, now the DNS resolution is basically to, to allow your VPCs to resolve, all right, DNS names to IP addresses. Okay, and that has to be enabled actually. The DNS host name is that when you create a resource, maybe you create an EC2 instance, you want the EC2 instance to have, all right, an host name. Okay, so something like, IP-, the IP address, and all of that. So you want that to have an host name, and of course you can change the host name. And the host name is actually optional, and that is why by default it is what? It is disabled. Because whether your resource has host names or not, it doesn't affect access or how you access that particular resource. What is important is the DNS resolution, because you want to access something from the internet, you want to, configure some kind of IP to host, to host name mapping. There has to be some resolution in place to do that. Okay, so VPC has been created. Now, if you click on subnet, of course, we still have our default VPC, subnet right here. So what I can do is I can click on this filter by VPC and then click on the class VPC, right? And of course, that does not have any subnet just yet. So I'm going to come here and say create subnet. And when you're creating a subnet, of course, it is a subnetwork. So you are creating a subnet from a VPC. Right? It is not an independent resource, right? It is actually connected or tied to a VPC, right? So here I'm going to say, all right, the VPC is the class VPC. That's the VPC that I want to create a subnet for. And here, all right, subnet 1 of 1. So which means you can have as many subnet, all right, as you want, right? The fact that you have 3 availability zones or 4 availability zones does not mean you can only have 4 subnets. Right, you can have 10 subnets, you can have 30 subnets, depending on the number of resources that you want to create, all right, and of course, whatever it is that you're doing. And then the subnet name, so we can call this subnet, all right, we can just say class subnet, all right, so let's say class subnet A, for example. Now, availability zone, I can come here. So I have 4 zones. So there's 2A, 2B, 2C, and 2D. So I'm going to put these, all right, in 2A. And this is my IPv4 CIDR block for the VPC. So for my subnet, I need to give my subnet, all right, a CIDR block as well. And of course, the CIDR block is actually, all right, derived from the CIDR block of your VPC. Okay. So I'm going to say 172.31.0.0/20. /20 is still captured within, all right, the /16 CIDR, all right, block. So I'll come here and say create subnet. So subnet has been created. So I'm going to create another one, all right, and I'm going to choose the same VPC, right? And I'm going to call this one subnet, class -subnet, all right, the B, okay? And I'm going to come here and I'm going to choose my availability zone. Now, one thing you will notice here is that when we created our VPC, we didn't have to choose an availability zone. All right. And that is because your VPC is a regional service, but your subnet is actually specific to the availability zone. Okay. But at the same time, like I said, as far as the subnet belongs to the same VPC, resources created in your subnet can actually communicate with one another. Okay, but your subnet must be placed at least in one availability zone. So I'm going to come here and choose 2B, and then here I'm going to do 172.31.16.0/20. Now, if you don't understand what I just did, I will encourage you that you watch, all right, a networking video where we actually explained, all right, subnetting, where we talked about the binary to decimal, all right, conversion. So, I mean, if you watch that video, you will understand exactly what I'm doing right now. All right, and then I'll create my subnet, all right, and I can see that I have the second subnet created right here. So I have two subnet, class A, all right, class subnet A and class subnet B, and my subnet belongs to two availability zones, all right. Now I have created a subnet, all right, and then I've created the VPC and all of that. And if I come here to my route table, all right, and I refresh a bit, I will see that I have a default, all right, route table right here. And that default route table is connected to my class VPC. Okay. Now I have created a VPC. I have created a subnet. So the question is, what is the next thing that I need to do? Right now, depending on, how I want my resources to be accessed. So do I want my resources to be accessed directly from the internet, or I want my resources to be shielded, all right, from direct access from the internet, right? That will determine the kind of gateway that I will create. But regardless of the access to your resources, you still need the internet gateway. Because whether you are going to be shielding your resources from the internet, your resources will still need some form of connection to the internet in order for them to download an update. And your NAT gateway, at the end of the day, still needs internet gateway to perform its function. All right? So whether you want to shield your resources from the internet or not, you'll still need an internet gateway. And quite often your NAT gateway, in fact, most of the time, right, the NAT gateway needs the internet gateway to perform, all right, its function. Is that okay? So here, I will come here to internet gateway. Now, for this particular VPC that I just created, I don't have any internet gateway already. So I'm going to come here and say create internet gateway. And by the way, creating an internet gateway does not cost you money on AWS. I mean, it's one of the free resources that you can create on AWS. All right. But the NAT gateway is actually not under the free tier. So when you're creating a NAT gateway, you have to use it and delete it as soon as you're done. Okay. But the internet gateway that will not cost you anything. All right. On AWS. So I'm going to come here and say class, all right, internet gateway, all right, class IGW, and then I'll create, all right, that. Now, when you create an internet gateway, the next thing you need to do is to attach your internet gateway to a VPC. All right, you need to attach it to, all right, a VPC. As you can see from here, it says the state is what? It is detached. Okay, and the way it works is that it is a one-to-one mapping. So which means you can map one internet gateway to one VPC. Right? You can't have one internet gateway connected to multiple VPCs. That is not possible, right? So your internet gateway is going to be mapped to a single VPC. So if you have another VPC that you have created, you can create another internet gateway and map that internet gateway to that VPC. And that is exactly the way it works. Okay. So here, I'm going to come here to say attach to a VPC. And right here, I'm going to select my VPC. Now you can see that I'm not seeing the default VPC because that default VPC already has an association with an internet gateway. So I'm going to see the only VPC that I'm going to see here is the VPC that does not have any attachment to, all right, the internet gateway yet. Okay. So I'm going to select this and I'm going to say attach internet gateway. And now the internet gateway, all right, has been attached. Okay. So at this point, I'm sure you're wondering, so now that we have attached the internet gateway to the VPC, can this VPC, all right, can we start creating resources and the resources will start, having access to the internet and things like that? Unfortunately, at this point, your resources still do not have access to the internet until you have completed the configuration in the route table. Okay. So let's go ahead and see how to configure, all right, our route table. So I'm going to click on route table. Now remember, I said your VPC, all right, has a default route table. But the truth is that you can actually create your own route table. I mean, you don't have to use the default. In fact, in a work environment, I mean, we don't use anything default. We actually create our own route tables. Okay. So you have to create your own route table, whether for your internet gateway connection or for your NAT gateway connection. So I'm going to come here and create a new route table, and I'm going to call this class, all right, RT, or I'm going to say class public, all right, RT. Now I'm going to explain to you why I'm putting the name public. Here, I'm going to select the VPC. So I'm creating a route table for the VPC that we created together, right? And I'm going to create a route table. Okay. Now, I have a route table created, but if you look at what you have here, the route table has only just one route, and that is a local route, okay, which means the resources that I have within my VPC will be able to communicate with one another, but right here, I don't have any connection to the internet gateway. So which means if my resources are trying to access something that is not available locally, they won't have any way or any gateway to point them in the right direction. So what do? I can come here and say edit route, and then I'll come here to say add route, and right here I'm going to say 00, which means anything that my resources or services cannot find locally, all right, then look to this target. So you have a lot of target here, right? I mean, you have carrier gateway, you have transit gateway, you have internet gateway, you have NAT gateway, a number, all right, of targets. But our own target is what? Is the internet gateway. So I'm going to select the internet gateway, and I'm going to click here, and it's actually going to show me the internet gateway that I just created, right? I'm going to select that, and I'm going to say save changes. Now, if I look in my route, I have an internet gateway configured in my route table, and then the status is what? It is active, okay? Now, the next thing I need to do is to basically associate the two subnet that I've created to this, all right, route table. So I'm going to click on subnet association. All right, and if you scroll down, there are two things. There's explicit subnet association and there's subnet without explicit associations. Now, these two subnet are not explicitly associated, all right, to this route table. Now, whether they are explicitly associated or not, the fact that I have configured a route to the internet gateway basically gives the subnet access to the internet as well. But in a work environment, you want to associate your subnet explicitly, all right, in your route table. I mean, so that you can know that this subnet actually belongs, all right, to this particular route table. So I'm going to click on subnet associations, and I'm going to click on edit subnet association, and I'm going to select these two subnets, right, and I'm going to save the association. Okay, now I have saved the association, and that is done, right? So now these two subnets explicitly belong to this route table. Right? Now, let me just explain something. Now, oftentimes in an interview, they ask you the question, what is the difference between a public subnet and a private subnet? Now, a public subnet is not identified by the name that you give to the subnet or by the tag that you give to that subnet. Right? A public subnet also is not identified by the tag that you have here. I mean, here I have my route table name class public RT. Right? Now, that is not enough to say or to conclude that, oh, this route table, any subnet that I see associated with this route table is a public subnet. No. The way you identify a public subnet is by looking at the route session. In this route table, I can see here that I have a route to the internet gateway. Now, any subnet associated with this particular route table is deemed, all right, a public subnet. Because it means that any resource that I create, all right, using any of the subnet here is actually, all right, a public resource, which means they are resources that are what? Internet facing. Okay, that is how you identify a public subnet. Okay, so when you want to identify a public subnet or a private subnet, where to look at is your route table. So go to the route table, look at the route session, and look at the route configuration. So if the target is pointing to an internet gateway, all right, I mean, it tells you explicitly or expressly that your subnet, all right, they are what? They are public subnet. But if I look into my route table and I see a target to the NAT gateway, I know clearly that the subnet associated with that route table is what? Is a private subnet. All right. So in the next video, we're going to go ahead and do a little tweak to our subnet, and then we're going to create a resource on our EC2. All right. Maybe just create an EC2 instance, and basically to help our understanding of a public, all right, subnet, all right, and all of that. So in the next video, we're going to see exactly, all right, how to do that. And of course, we move on to other interesting things. And of course, we're going to create our own NAT gateway and just compare the difference between a NAT gateway and, all right, an internet gateway. So thank you, and I'll see you on the next one.